Good morning everyone. Today we are going to discuss about the another type of chromatographic technique, that is thin layer chromatography. Till now we have discussed about the column chromatography in the two types, adsorption chromatography, partition chromatography, and next our topic is thin layer chromatography. This is also one of the chromatographic technique, but based on the name itself it was telling that here we will use one thin layer plate, either the aluminum plate or glass plate. It should be very thin layered. That's why the name called as thin layer chromatography. Whereas in column chromatography, either column partition chromatography or column adsorption chromatography, we are using one column, glass column. That's why the name called as column chromatography. Here the name is thin layer chromatography. That means here we are using chromatographic bed is one thin layered aluminum plate or glass plate. That's why the name called as thin layer chromatography. Coming to the history, so many different scientists have used this chromatographic technique, but they didn't give a specific name or they didn't identify it as a very accurate process for separating different types of components. So for example, first of all, Edgemolov and Scharaber, they used to identify or isolate different type of plant extracts. First of all, they have used the one thin layer aluminum set on the glass plate. That means they have taken one glass plate, on that they have spreaded the aluminum layer in a thin form, and they extracted different plant extracts by spotting those plant extracts on that glass plate, but they didn't separate it nicely. That means, however, they have introduced firstly, but they didn't identify it correctly as a thin layer chromatography. And after that also so many scientists like Kirchner also have identified so many compounds by using the alumina, paper coated alumina or paper coated glass, so and so. But finally one scientist called as Stahl developed standard equipment. That means from him onwards, that means after he discovered the standard equipment, he introduced the name as thin layer chromatography. That means all the scientists have used so many things, but they didn't recognize or they didn't give an idea it as thin layer. But Stahl have given or developed the standard equipment for analyzing the thin layer chromatography. This is about the introduction part, because for everything you have to know what are the things, background which are present to give a nice separation technique. You have to know the history also. Coming to the next one, principle. Thin layer chromatography is based on the principle adsorption. Understood? Not partition. You have to know the main principle of separation in thin layer chromatography is adsorption. That means based on the binding interaction or based on the affinity, the separation of components of a mixture will take place. First of all, here what will happen, whatever components or the mixture of components which we want to identify or which we want to separate, we have to mix with them, or we have to take finely divided adsorbent coated on a chromatographic plate. That means first of all we have to take one chromatographic plate, either aluminum made up of plate or glass made plate. We have to take that glass plate or aluminum plate. On that you have to add the stationary phase. That means we have to take mostly stationary phases. What you will take? Silica gel. You have to take the silica gel and you have to mix it with some solvents or mobile phases, and you have to spread that adsorbent or stationary phase which is mixed with the solvent on that glass plate or aluminum plate uniformly. Understood? First you have to take the plate. Anyway, we will discuss that one in the procedure, but how the separation will take place you have to know in the principle itself. That's why I am telling you, first you have to take the glass plate or aluminum plate. On that you have to spread the thin layer of adsorbent or stationary phase. Already we have prepared it in a slurry form. That means by taking the stationary phase, especially silica, and you have to mix it with the solvent or mobile phase, and that slurry you have to spread on this glass plate or aluminum plate, and then you have to dry it. After the dried one, on that dried one you have to apply the components or mixture which you want to separate. That means after the plate is completely dried with the stationary phase. On that stationary phase you have to keep our sample spots, and whatever the components which are present in that sample, if those components are having more affinity with the stationary phase, it will take very large time or very big time, or it will take more time for eluting along with the mobile phase. If the component is having more affinity with the mobile phase, then it will elute or it will move fast along with the mobile phase. You already know, whenever we are applying this component on this slurry mobile phase, you will keep that slurry applied plate in the beaker which is containing mobile phase. First of all, we will take the plate, and on that you will apply the absorbent, and you will keep that plate in the beaker containing the mobile phase. The mobile phase will undergo elution, and the samples which you spotted on that slurry or the stationary phase, if that sample is having more affinity with the mobile phase, it will fastly move with the mobile phase. If that sample is having more affinity or binding interaction with the stationary phase, it will take more time to get eluted. That is the main thing. That means the adsorption capability of the component which is present in the mixture will be the main thing for separation. If it is having more adsorption with the or more interaction with the stationary phase, it will elute slow. If it is having more adsorption capability with the mobile phase, it will elute fast. Okay, this is the main principle which is happening in thin layer chromatography, that is adsorption. And coming to the next thing, what are the practical requirements? That means how we will do the thin layer chromatography. What are the different steps and what are the different requirements you will see. First of all, stationary phases. That means what type of stationary phases we will use, and what type of glass plates or the TLC plates we will use. Mostly I already told you, we will take the TLC plates, either aluminum plate or glass plate, mostly glass plates. And after taking those glass plates, how we will prepare those glass plates, that means how we will apply the stationary phase on that, and how we will activate the TLC plate for the separation of the components, and then how we will apply the sample on that TLC plate, and then how you will keep that sample applied TLC plate into the mobile phase tank, that is called as development tank, and then how the development will takes place, and what type of mobile phases we will use, and finally how the development or elution will takes place, finally how you will detect the eluted sample. These are the different steps which are happening in the TLC, and not only these are the different requirements for the experimentation part of the TLC. So each one we will see one by one. First of all, stationary phases. As you already know, there are several types of stationary phases or adsorbents. I already told you different chromatographic terms in the previous first class itself. We can also call the stationary phase as adsorbent also, because it will adsorb on the plate. That's why it is called as adsorbent. Different types of stationary phases or adsorbents we will use in the TLC. And not only that powder stationary phase, here in the TLC we will make it into a slurry. Slurry means nothing but, for example, you are taking the silica gel powder. It is a solid form, but in TLC chromatography or thin layer chromatography technique, whatever the powder silica gel we will take, that one we will mix with the different types of solvents or binders or mobile phases to make it into a semi-solid form. That is called as slurry. Okay, don't get confused. It is not a big thing or big term. Slurry means the stationary phase or adsorbent mixed with the solvent or any binder or mobile phase. Okay, that is called as slurry. So here I have given you few examples regarding what type of stationary phases we will use. First of all, silica gel H. Silica gel means it is a silica gel powder, silica containing powder, commonly used stationary phase. So what is meant by silica gel H? H means high grade silica gel. High grade silica gel, that means only silica gel powder we will use. That too, H means high grade silica gel powder we will use, and that silica gel we will add water in the ratio of 1:1.5. That means if you are taking 1 part of silica gel powder, you have to add 1.5 fifth part of water. Other things, that means for separation of other types of mixtures, we may use silica gel G. Silica gel means G means silica gel powder. What is meant by G? G means binder. Here, along with the silica gel, we will add calcium sulfate binder also for the good binding capability, and for better separation we will add this calcium sulfate and silica gel, and this composition we will take in 1:2 ratio. That means first of all we will take the silica gel and calcium sulfate binder and we will mix it thoroughly, and then to that you have to add double the volume of water. That means if you are taking one part of silica gel with calcium sulfate, you have to add 2 parts of water to make it in a proper slurry. Okay, and other thing is silica gel GF. GF means in the name itself it was denoting silica gel powder plus silica gel powder plus binder, and then F means fluorescent indicator. For few types of samples they need, that means for few types of samples means if they are very complex, if they are having the fluorescence exhibiting property, then for those type of components we can use the another thing, fluorescence indicator also. That means you have to take the silica gel powder, to that you have to add the binder for good binding and lubricate to act as a good binder and lubricating agent and for better separation, and also you will add the fluorescent indicator if the components which we are going to separate have the fluorescence emitting property, and you will add the double the volume of water and you will prepare good slurry with thorough mixing. These are the different types of stationary phases we will use, and how the stationary phases will make into slurry in what ratios also here you are having. Okay, next, glass plate. First of all we have seen what are the different types of stationary phases or adsorbents we will use, and then we will see that slurry or the stationary phase or adsorbent whatever you have prepared in the form of slurry, where you will apply on the TLC plate. So that TLC plate mostly is made up of glass. That means mostly we will use the TLC plates which are made up of glass only, because the glass is very inert. It will not react with the components which we are separating or the stationary phase or with the mobile phase also. Okay, so mostly the dimensions of the TLC plate we are taking is, if it is 20 into 20 length into diameter, 20 into 20 we can take, 20 into 10 we can take, and 20 into 5 also we can take. Those are the dimensions of length and diameter of the glass TLC plate we are taking. All these dimensions we can take. That means all these 3 types of dimensions of glass TLC plates we can use for the TLC separation technique. And mostly I already told you we will use the glass plates. Why? It is very inert and it will be very adaptable for good separation, and mostly whatever the glass plates we are taking, it should be of high good quality. Why? Because it should be inert and should be good quality, and it should have a high durable or high durability, and also one of the most important thing is it should withstand the high temperature conditions also, because we will dry the plate after applying the slurry. So it should withstand, it should not be fragile or breakable. That high quality TLC glass plate we have to take. Okay, next, after taking these glass plates, what we will do? Preparation and activation of these glass plates. First we will take the stationary phase and you will mix it with the water to make it slurry, and we will take the glass plate of required dimensions, and after that, after taking these 2 parts, stationary phase slurry and then glass plate, what you will do? We have to apply that stationary phase slurry on this TLC plate. That is called as preparation of TLC plate. Preparation of TLC plate means whatever the stationary phase slurry we have prepared, we have to apply on that glass plate. That is called as preparation. We can use 4 types of TLC plate preparation methods. One is pouring, and another one is dipping, and another one spraying, and another one spreading. So by using these 4 techniques we can apply the adsorbent or stationary phase slurry on the TLC plate. So first one, pouring. Pouring technique means in the name itself it was denoting that whatever the slurry we have prepared, we have to pour on the glass TLC plate. First we will take the slurry, and whatever the prepared slurry is there, we have to pour it on the glass plate uniformly and very carefully, because whenever we are applying the slurry on the TLC plate will be like this, and from starting onwards till the end you have to apply the slurry, or you have to pour the slurry with uniform thickness on all the sides and also on the middle surface. Overall surface should be uniform. At one place it should not be more slurry, at another place should not be less slurry, like that. The whatever slurry we are applying on the plate, it should be uniform. But the main disadvantage of the pouring technique is there will be no uniform thickness on overall the TLC plate, because we are just pouring it. Maybe while we are pouring, sometimes it may apply, or it may fall more amount on edges, or less amount on the middle part of the TLC plate. That's why the main advantage of pouring is there will be no uniform distribution of the slurry. And the next one is dipping technique. In the name itself it was denoting that we will dip something. Here in the dipping technique, what you will do means, we have to take the two TLC plates, one TLC glass plate and another TLC glass plate we have to take. We have to attach both like this. See, you think that this is one of the TLC plate and this is another TLC plate. Both TLC plates we have to attach like this. Okay, and you have to take stationary phase slurry in one beaker, and you have to attach these two TLC plates like this, and then you have to dip in the beaker containing the stationary phase slurry, and you have to remove it out. What will happen? Only the surfaces of the two TLC plates which are open to the slurry, they will be covered with, or they will be applied with the slurry, and the other surfaces which both are not applied or not shown exposed to the slurry, they will be empty only. Understood? Two TLC plates you have to take and you have to join like this, and the joined TLC plates we have to dip in the slurry containing beaker, and you have to remove it. What will happen? On the both sides, one sides of the TLC plates are covered with the slurry. And also here what will happen, because of the dipping nature or dipping technique, what will happen? Large quantity of slurry is used here. The main disadvantage is what is happening, because of the dipping, more amount of slurry is being used by the dipping technique. So that is main disadvantage. And coming to the next preparation technique, spraying technique. In the name itself it was denoting that we will spray the slurry. That means what we will take? We will take the slurry, and then we will take that slurry in the spraying bottle. And what will happen here? Whatever TLC plate we will take, or the glass plate we will take, on that glass plate, by using this spray bottle, that spray bottle is containing the stationary phase or slurry. So we will spray the slurry on the TLC plate. What will happen? Whenever we are applying high pressure on the spraying bottle, more amount of slurry will be sprayed. Sometimes maybe at every time we can't apply the same pressure on the spray bottle, no? So wherever we are applying the less amount of slurry, maybe they applied that means little bit amount of slurry may not be applied on the glass plate. That means whenever we are doing the spraying technique, or whenever we are spraying the slurry on the TLC plate, sometimes or at some places more amount of slurry may be sprayed, at some places less amount of slurry may be sprayed. That's why this, like pouring technique, spreading technique also is having main disadvantage, that is there will be no uniform spreading of the, or uniform applying of the slurry. And finally the spreading technique. This is the best technique and commonly used, and it is not having the two problems which are already discussed techniques have. Those are, there will be no problem of ununiform distribution of slurry, and there will be no problem arises with the spreading technique, like usage of large quantity of slurry. These are all the two disadvantages we have faced with the previous techniques. Those are dipping, pouring and spreading, spraying. But with spreading, We will not get the two problems like no uniform distribution of slurry and more amount of slurry usage also. That spreading technique, here we will have one spreading equipment. That means there will be uniform spreading of the slurry on the TLC plate by using one spreading agent. Here we can take the glass plates of dimensions 20 into 20 length and diameter, 20 into 10, 20 into 5 also, and the slurry whatever we are applying, we have to take in one equipment called as spreader. And the thickness, how much thickness, how much mm of thickness of slurry we have to apply on the plate also, we can initially only we can adjust. I will show you the equipment. See, this is the slurry spreading equipment. This is the spreader. This is the spreader. You can see this bowl like structure is having the slurry, whatever slurry that is adsorbent or stationary phase mixed with the water, that slurry we will fill in this bowl like structure. And here you are having two knobs. This big one is one knob and this small one, totally two knobs are there. This big knob is for adjusting the or filling and applying of the slurry. If you adjust that knob, whatever slurry is there, it will be poured on the plate. And this knob is for adjusting the thickness of the, that means with how much thickness we have to apply the slurry on the glass plate. If you want to adjust, this knob we have to use. Okay, understood? First of all, this spreader is having one base plate. On that base plate we have to keep our glass plate or TLC plate, and after keeping that glass plate you have to apply our slurry. If you turn this knob, the spreading will be takes place. The spreading of slurry will be takes place, and previously only we have to adjust the thickness of how much slurry we have to apply on the glass plate. Like here, see, they have adjusted for, I think this is very less, 0.5 mm thickness. Already they have adjusted. Based on the adjustment of the thickness, the slurry is poured. Because of the already adjusted thickness, there will be uniform thickness on the overall glass plate. There will be uniform thickness on the overall glass plate. Understood? See, there will be no disadvantage of ununiform thickness because already we are adjusting the thickness of the slurry, how much thickness we have to apply. That is the main advantage of the spreading technique. And also here, because of this, the plates are having uniform thickness, and uniform drying also will happen, because after applying the slurry on the TLC plate, we have to dry it by keeping in the oven. So whenever it was going for dry, because of the uniform thickness on overall the plate, there will be uniform drying also, and there will be good separation of the components finally. Okay, that is the main advantage of spreading. And the next step is activation of TLC plate. Activation of TLC plate is nothing but drying of TLC plate. First of all, we will take the TLC plate, and on that we will apply the slurry by means of mostly spreading agent or spreader. After applying the slurry, we have to dry it. That is called as activation. Activation is nothing but here we will dry in an oven at 100 degrees or 120 degrees for 1 hour for the complete or uniform drying. Why we have to dry it? Why means, if you dry or keep it in oven, what will happen? The TLC plate will get activated. That means it was getting ready for good separation of the samples whatever we are applying on the TLC plate. And one more thing is, nothing but activation is nothing but we are making the TLC plate with applied slurry. We are making the plate will be removal of water or moisture content or any impurities. That means we have to do the drying or the activation of the TLC plate to remove the moisture content or to remove the any air bubbles or water bubbles, and to remove the impurities whatever are present on the TLC plate. That is called as activation technique. Okay. And the next, after preparation and after activation, what we have to do? We have to apply the sample on the TLC plate. First we will take the TLC plate, on that we will apply the slurry, and then we have to dry it, or it is called as activation. After it is completely dried or after it is completely activated, we have to apply our sample. Sometimes at few places or in the industries, they have some micro pipettes or micro syringes. What is the use of those things? Means if you want to apply the sample in very less quantities, like microns, nanos, at that time we can use the micro pipettes. But mostly in the colleges, they will use the capillary tubes. If the micro pipettes or micro syringes are not available, we can use the capillary tubes. By using the capillary tube, we have to spot the sample mixtures on the dried TLC plate. And before applying the sample on the TLC plate, we have to apply 1 inch above the base. For example, this is the TLC plate. On the end, you should not apply the sample. 1 inch above the TLC plate, you have to start applying the spots. And whatever the samples we are applying, for each sample spot, there should be 1 centimeter distance gap. You have to 0.5 centimeter gap. You have to maintain, because whenever it was getting eluted, if you are applying the samples very nearer, there will be occurrence of co-elution, or there will be mixing of the elution. That's why if you are keeping one spot here, and after that you have to give 0.5 centimeters distance for application of the second sample spot. And that sample spotting also you have to start 1 inch above the base of the TLC plate. These conditions you have to know before applying, and it should be, all the spots should be mostly with equal distance. After applying the spots, you have to wait for some time to get the spots dried, or they get to be inculcated with the stationary phase and mobile phase. After applying the spots, what you have to do? The next step is development tank. That means first we will take the TLC plate, on that we will apply the slurry, and that applied slurry you have to dry it. That is called as activation. Whenever the TLC plate with the slurry got activated completely, we have to apply the spots. That plate with the sample spots you have to keep in the tank called as development tank. Why it is called as development tank? Means in the tank only the development or elution of the samples with the mobile phase will takes place. That's why the tank is called as development tank. In the colleges, usually they will take big beakers, but in the industries they are having special development tanks called as specimen jars or glass jars. Mostly in the colleges they will use the big beakers, but in industries they are having separately or highly prepared development tanks or jars. You have to take mobile phase in the development tanks or jars, and then you have to keep carefully this plate which is with stationary phase and the sample spots into that development tank very carefully. Understood? The development tank is the tank in which the development of the elution of the samples will takes place. Those dimensions of the tanks are very must if they are doing in the industries, but in the colleges they will use big beakers, and in that beakers we have to apply the take the mobile phase. In that we have to keep the TLC plate. Okay, you can see this in this picture. See, this is the development tank, and they have kept the slides or the TLC glass plates without disturbing one by one. That much careful you have to be. This is the development tank which can be taken in the industries. For each, you can get the doubt, ma'am, see the glass plates or TLC plates, how they are like this without touching each other. They have that much, they have some thing here. After keeping the each TLC plate, they will have some edges to separate those two. One slide after one plate they will have something knob like structure which will separate the plates. Why? For more TLC plate development they will use this type of big development tanks. But in our some pure less pure in the small industries or in the colleges, they will use the glass beakers, okay, or jars. In that we can keep only one TLC plate. Okay, first of all we will take the jar, and in that we have to take the mobile phase, and after that plate we have to keep very carefully. And one more thing is another jar which is having one hump. You can see the hump. Hump means one small divot or one hard like structure which will separate the base of the beaker into two halves. Why this hump? What is the use of this hump? Means we can keep two TLC plates in one jar itself, and this hump will divide these two TLC plates. What is the use? What is the use means at a time we can develop the two slides. Here we can develop only one TLC plate, but here because of this hump we can keep at a time two plates, and two plates will undergo elution at a time. This is the thing which is happening. Till now we have discussed about the stationary phases, whatever we are using, how the slurry we will make, and how we will apply the slurry on the TLC plate. After, how we will do activation, that is called as drying, and after that a dried TLC plate, on that how we will apply the samples, and after applying the samples how we will keep in the development tank we have seen. So in the next class we will see how the development will take place, what mobile phases we will use, all those things we will see. Thank you.